Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on Laplace transformation, lecture number 10, which will include convolution theorem, its example, and some more problems related to different, for example, division by t, multiplication by t, derivatives of inverse Laplace transformation, integral of inverse Laplace transformation, first shifting theorem, second shifting theorem, change of scale property, etc. Now we shall define convolution. Let ft and gt be two functions of class A. Then convolution of two functions ft and gt be denoted by f star g and is defined by the relation f star g equal to integration limit 0 to t fx gt minus x dx. The relation f star g is also called the resultant or faulting of f and g. Now we shall show that f star g is commutative. Since f star g equal to integration limit 0 to t fx g t minus x dx. This is number 1. Now g star f equal to 0 to integration t gx f t minus x dx. Now let t minus x equal to y. When x equal to 0, this is the integration for the variable x. Value of x is 0. Then y equal to t. When x equal to t, then t minus t equal to 0, then y equal to 0. Again, differentiating both sides, minus dx equal to dy implies that dx equal to minus dy. Now from 2 g star f equal to, our limit is y equal to t and y equal to 0. Here g x equal to t minus y. Gx x means t minus y, and f t minus x equal to y, dx equal to minus dy. So g star f equal to, this negative sign and limit, lower limit is t, higher limit is 0. So we may write 0 to t limit g t minus y fy dy equal to, now we replace the variable y by x as it is a definite integration. So we may replace the variable, so this 0 to t g t minus x fx dx equal to 0 to t fx g t minus x dx. This is number 3. From 1 and 3 we get that right side is equal, therefore left side is equal. So we may write f star g equal to g star f. Therefore convolution is commutative. Let ft, gt and ht be three functions of t. Then convolution of three functions is associative, that is f star g star h equal to f star bracket g star h. This is associative, and also distributive. F star bracket under bracket g plus h equal to f star g plus f star h. We may prove this very easily. Now we shall prove the convolution theorem in Laplace transformation statement. Let ft and gt be two functions of class A, and let L inverse fp, means inverse Laplace transformation of fp is capital Ft, and L inverse small gp equal to capital GT. Then we have to prove that L inverse fp into gp equal to convolution of f and g, that is f star g. We shall prove this. Since given that L inverse p equal to ft, L inverse fp equal to ft implies that L ft equal to small fp and L inverse gp equal to gt implies that L gt equal to gp. Now L f star g means convolution of f and g equal to 0 to infinity Laplace transformation, 0 to infinity e to the power minus pt f star g dt equal to 0 to infinity e to the power minus pt f star g is 0 to t integration fx g t minus x dx here dt. equal to, let limit t tends to infinity, here 0 to t, here this is the value of t equal to 0 to capital T. Here 0 is the value of x equal to 0 to small t, e to the power minus pt fx g t minus x dx dt. That this is number 1. Now let we transform this integration in another variable. Here variables are given x and t. We will change these variables into uv, where x equal to u and t minus x equal to v implies that t equal to x plus v equal to implies that t equal to x means u plus v. So we get relations between two pairs of variables, from one set of variables to another set of variables, x equal to u and t equal to u plus v. Here we have to select the limits of the integrations as x equal to 0. When x equal to 0, then u equal to 0, and x equal to t, then u equal to t. Again, when t equal to 0, t equal to 0 and u equal to 0 initially, then v equal to 0. When t tends to infinity, then v equal to 0, t tends to infinity, then v tends to infinity. But here value of u equal to t and t tends to infinity. That means maximum value of u is infinity. So maximum value of u, max u equal tends to infinity. So we get the limits as u equal to 0, u equal to infinity, and u equal to infinity, v equal to 0, and v equal to infinity. So we may take the limit of the integration containing variables u and v, but it is to remember that when we change the integrations from one set of variables to other set of variables, in that case Jacobian plays an important role. So firstly we have to find the Jacobian. Del xt, first set of variables, this uv, second set of variables, equal to del x by del u, del x by del v, del t by del u, del t by del v, equal to del x by del u. Here del x by del u is 1, del x by del v, here we have no v, so this is 0. Now del t by del u is 1 and del t by del v is also 1. So value of the Jacobian is 1. 1 multiplied by 1 minus 1 into 0. So we get new variables with their integration L f star g equal to zero to infinity and 0 to infinity integration e to the power minus p, value of t is u plus v, value of t is u plus v, then fu, gu, del xt by del uv Jacobian, gv, here gv, du, dv. So we may write this 0 to infinity, this 0 to infinity, e to the power minus pu, e to the power minus pv, fu, gv, this is 1 du dv. Equal to 0 to infinity e to the power minus pu, fu, du, again limit 0 to infinity e to the power minus pv, gv, dv. We may change the variables of the definite integration. 0 to infinity e to the power minus pt, ft dt, 0 to infinity e to the power minus pt, gt dt. This is Laplace transformation of ft, and this is Laplace transformation of gt. This is small fp, this is small gp. So we may write L inverse fp gp equal to f star G. L inverse FPGP equal to F star G. Hence proved. Now we solve a problem of inverse Laplace transformation by using convolution theorem. Here the problem is find L inverse 1 by P plus 1 into P minus 2. Let Fp equal to 1 by P plus 1 implies that L inverse Fp equal to L inverse 1 by P minus 1 equal to e to the power minus t by the formula 1 by P minus a, L inverse P minus a e to the power at. Here a is minus 1. Let this is ft. Now let Gp equal to 1 by P minus 2 implies that L inverse Gp equal to L inverse 1 by P minus 2. This is e to the power 2t. Let this is Gt. By convolution theorem, L inverse Fp Gp equal to convolution of F and G, F star G. This is equal to 0 to t integration fx g t minus x dx. So this is equal to 0 to t integration ft is e to the power minus t. So fx is e to the power minus x. Gt is e to the power 2t. Gt minus x is e to the power 2t minus x. E to the power 2t minus x dx equal to 0 to t e to the power minus x e to the power 2t e to the power minus 2x dx. So this equal to, here x is the variable, so t is constant, treated as constant here, so we may take out e to the power 2t. Here remains 0 to t e to the power minus 3x dx. This equal to e to the power 2t. Integration of e to the power minus 3x is e to the power minus 3x by minus 3. 0 to t equal to minus 1 by 3 e to the power 2t. Here e to the power minus 3t, applying this, minus e to the power 3 into 0. So minus 1 by 3 e to the power 2t e to the power minus 3t minus 1. This is the required result. Thank you for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.